right? We have people and addresses. And if you look at it, right, we have like a person essentially just has one address. So we have this, person ID, first name, last name, and then we're connecting the person through the addresses table, right? So an address has one person, okay? And here we do, select all from the persons. So you can see we have like 3 addresses and we have 2 people. All right. So you already can see that there's basically like a mismatch. And in fact, that's even further. If you see, we just do a simple inner join right here. Select all from persons. We're going to join the addresses table, right, on persons.personid equals addresses.personid. All right. So this is only going to return to us one, and this is correct. It only returns to us one record. And the reason why is because even though there's 3 addresses here, if you look at the person ID, let's think about this. Person ID is here. The person ID that's a match is only this guy, right? The 1 isn't there, and then 3 and 4 also are not there. Okay, so the only case where the person ID exists, right, where a record and address has that person ID, is this record right here. So we do the join. That's all that we see, right, is this Bob Sanders, number 2. Now, of course, we kind of know, right, like, so now this gets us to outer joins, right? So how do we show them? So the idea is, which of the tables do you want to, load? Like, are you kind of fully loading up there? So if we do a left outer join, that means you're loading up the left table, okay? So all the records on the left table will be included, and when there is no address for the person, like Alan Wang, right, we're still going to have him there, but there's just going to be null values on the other side. So let's do that. Right, so you can see Alan Wang, all the records in the persons table is loaded up there, and we just have these null values where there is no corresponding address. Then right outer join, what does that do? We kind of know, right? It this time all the records in the persons table is going to be loaded. So what should we see? We should see, left outer join. Sorry, this is the left table is persons. The right table would be addresses. So all the records in the addresses table should be loaded. So we should see, 3 records, 1, 2, 3, and then right outer join the addresses table. We would see. Let's just see it. Hold on, we'll figure this out. Right. Okay, so we're joining all the addresses, and when there's not a matching person, right, we just see the null values. Okay, and then so that's the right outer join, and there's one other kind, which is full outer join. What does full outer join do? This is all of the records from both tables. Okay, so when there's not a match, you just get the null values, but we're going to see all of the 3. Here's all the addresses, right? All the 3 addresses. And we're also going to see the extra individual. Okay? So we'll do that. So the full outer join gives us full records because we get all of those where we have a person but not any address. We get where we have both. And then we get all of those where we have an address but we don't have a person. So this is the time that people always show this diagram, which is quite useful. Let me show it. So the diagram is essentially, this, which I think probably you guys have seen, right? This is my left table, right? This is my right table. So when we do a left outer join, all of the records from this table are included. All right, so let's say this is like my persons. So this whole shading is going to be included. And then when there's no match when there's no addresses, it's just going to have null values. When we do a right outer join, then everything in the right table is going to be included. So that's all the addresses, right? And when there's no match, when there's no people, right, it will just be null values, but all the addresses will be loaded. When it's an inner join, it's just where there's a match, right? It's just where we actually have a match of, right, the person ID actually has a corresponding person. And then when we do a full outer join, right, it's everything, both circles, right? So that's why we have, the 3 from one, and then I think it's like 1 on the other. Okay, so all the records are included. All right. So the next thing is questions before I move on from there, right? I think we've seen this before, but do ask questions if right, the whole idea of these joins, of these outer joins, is just that, as opposed to like an inner join where we only are returning those records where there is a match in the foreign keys, here we're returning all of the records, right? Left outer join, return all the person records, even when this person ID does not have a corresponding match over here. So we're still returning all the records, even though Alan does not have a corresponding match with his address. Okay? All right. So then the next thing is and this comes up pretty often in LeetCode, is kind of doing a count of maybe finding those individuals. We can find those individuals who do not have addresses listed. All right? So we can do something like that. So how will we do this? Well, let's just do a join for now. So we want to find all those individuals who do not have addresses listed. This just has where there is a match. That's not going to be it. So we want all of the individuals. So for that, it's join, include everything on the left table, which is all my people, right? So we have all the people listed. And then if I want to get a count of where there's no address, you can do, let's see. Well, we could do this, right? Let's say we did count of person ID. And now this is just going to, think about what this will count. This is going to count where there is an address, right? So this will be a count of 1, right? So this will be is address. Person ID is address, ambiguous column name, person ID. So we should have, you can see what's going on here. I need to put the table prefix. Right, if you see this error of an ambiguous column name, it means that we're loading 2 tables that have it, right? So we have it here, and we also have it here. So I just have to specify one of them. All right, so is address, I didn't think it would be 2. Oh, I probably have to do this. I'm sorry, guys. I probably have to do address.person ID. Addresses.person ID. So in this case, there's only one address where there is and I'll just show you this real fast. Right, we only have one address. Right, there only is one address.person ID. This is the only present value. So when we execute the query, this is the one that counts. And then if you want to find how many do not have an address, well then it's just, you can just do count star, right? Do all of them minus everything in the data set, all the records in the data set, minus those where there's an address, gives you the amount where there's not an address. So total records minus those with equals those without. All right? So that this is the formula. Okay? So here we're saying is no address is all of them minus those with, right? Okay, so this is right. One way to do this calculation is you just do total minus where it exists, right? Gives you the account of how many does not exist, right? Those records that don't have an address. And then there are other ways that we can do this, right? So let's go back to our original query. We can do like a full outer join. Does this make sense? Do you want me to go through this again? Right, we're basically doing, remember we can use the count, and this only shows me present values when we do this on a column, so the null values aren't counted, right? So basically this value won't count, all right? So if we do it here, if we do it on a full outer join, this will be all of my records where we have an individual where, say, we don't have an address, right? That would still just give us 1, right? Because we have 3 addresses here. Just show you that. All right, we have 3 addresses here. So that goes 3. Okay? And then if I minus all of them, that will still just give us 1, right? Because there's 4 total. Okay, so this is all of the records that, you know, where we have an individual but we don't have an address. It's still just 1. Okay, so the other way to do this is you can do like a case when statement, all right? And this does come in handy. So for instance, let's say we want to see let's start with the same kind of calculation. So all of the records, right, that we have where there is not an address, okay? So how will we do that? So we'll do something like select, and we'll do case when, and I always write this out, case when then end. So case when the address ID is null, then 1, else 0, right? So when we have an address ID of 1, then we'll just, of null, then we'll say, right, this is a case of no address. We can say as no address, right? So this is the examples where we have no address, and then from there we can just sum it, right? So we can add up all the cases where there is no address in this data set, and that gives us, you know, a total of 1, all right? And then we can do the same thing. Let me just show you this, and we'll put this up. Sorry about that. I wanted to do select all. Let's just look at our full data set. Full outer join. Okay. So in this case, what did we do? We used our case when statement to basically give us a 1 whenever we have a no address, right? When the address ID is null, then place a 1 there and finally add it all up. All right? So we get a 1 here. Now, what if we want to also add up the cases where there is a person, where there is an address, let's say, but there is no person. Okay, so where would that be? That would be right here. Right, we have an address, but we have no person associated with it. So this is very similar, right? So it's case when the person ID. We could do persons dot person ID. So this column is null, then 1, else 0, end, right? As no person. And also sum this up, right? So here it's going to be a 1 because there's no person. Here it's going to be a 1 because there's no person. So if you add these 2 up, we should get 2. And I broke it. Commas. I'm missing my commas. No address, no person. Okay, so this is where there is, no address. This is where there is, an address but no person associated with it. And then, so we saw that there is 2 records there. And then if you want to get the total, right, you just do count star, right? Count star is like all records. Okay, so there's 4 records. So I just want to show you, like how you can get these like aggregate statistics. And you can think of this as like orphan records, right? Orphan records meaning like you have some of the information, but you're missing, right? We have like kind of the person here, but we don't have the address. In this case, we have the address, but we don't have the person, right? So this record's missing its partner in a way. All right, so you can think of this as like how do we count up the orphan records in a data set? A good way to do that is using the left, this outer join, and then counting the nulls. And there are 2 ways we saw to count the nulls. One is you can do like count present and count all of them minus the present values. So 4 minus the 3 present values is going to give you the 1 orphan. And then the other way we can do this, and this is especially useful when we want to kind of like get aggregate orphans on 2 different columns, is to do this case when, right? When it's null, then do a 1 and then add them up. And here, when this column is null, then do a 1 and then add it up. All right? Questions on that? Any questions on any of this? Because like obviously what's kind of coming next is like some of the elite code problems that ask you to do this. No? Okay. You sure? We're awake? Okay. The next thing is self-joins. People have gotten jobs because of self-joins. Can you believe it? Let's see. All right. So let's say we have... why is this... Did I not... I'm surprised. It says customer... Yeah, customer DF is not defined. This probably should be students DF. All right. So take a look at this data set. So there's kind of like 2 use cases for self-joins. This is the main one, probably. And this is a self-referential data set. So just understand this for a second. We have like, Bart, Maggie, and Lisa. These are like the kids, but they also can help each other learn. So in this case, Bart's tutor has a tutor, which is Lisa, okay? And Lisa has a tutor, which is, Maggie. Which is Maggie. So if you want to, like, answer this question of, well, who is Bart's, tutor? Like, give me the name of Bart's tutor and give that to me in SQL. The way you need to do that is with a self-join. Okay, so we'll do select all from students. And the way you do it is you'll do join students again, and you'll give it an alias. So we'll say like as tutor. And I actually just put the word tutors, right? This is the alias. And then we just reference this like it's a different table. So then it's on tutors dot tutor ID. And it probably should it will say students dot ID equal. Oh, sorry, I might have. So join students. We're going to reference the students table as tutors, and then we're joining it on. And we'll say No, I like this better. I think. Join the tutors table on tutors dot tutor ID. So this thing right here equals students dot ID. Okay, equals this right here. I think this will work. Let's see it. So if I have, here's Bart. Bart has a tutor ID of 3. And I think, did I mess it up? Man, I think someone's helping me anyway. So Bart has a tutor ID of 3. Join students tutors on tutors.tutor ID. Oh, it should be students.tutor ID. Students.tutor ID. So this student's tutor ID equals tutor. Yeah. Yeah, I could do this. Tutors.id.
Who's that tutors? Yeah, tutors.id. Yeah.
Yeah. There we go. So think of it as like the left and right tables again, which is what helped me kind of solve it. It's students.tutorid, right? Students table.tutorid equals the tutors.id. Okay, so we're loading up both tables, and then we're saying how we're linking. It's just the same thing as normal. We're saying how we're linking them together. The main trick is you load up this same table twice, and you just call it a different name. All right. So select all from students. This is my left table. Join students again, and join it on students.tutorid equals the tutors, this table, tutors.id. And that's linking the rows right together. Yeah, Miles?
Sorry, did you say join it on the same name or a different name?
It's joined on a different name. Like you're referring this to this table as like as a different name. It's almost like It's almost like having a second It's basically like having a second variable, but the same data, right? So to SQL, you can think of this as like a different table. If it helps, you can think of it like we actually have two duplicate tables in the database, right? And we're like with duplicate data, and then we're joining them on these columns.
Okay.
Did that answer?
I gotcha.
Yeah. So it's students.tutorid. We're referring first to this table, and has a foreign key right here, and then second, now we're using the second table that we basically loaded, and joining it on joining the primary key. Right, that's how these two tables link. All right.
We're talking about the same table twice.
Yes, it is the same table of data.
Right. How does it know that we're talking about the same table twice with two different names?
Because when I join, the key part is right here. So I'm loading, select all from students. I'm loading up the students table. Then I join students again, but reference it as tutors.
So it's almost like I'm saying students as tutors,
Exactly.
but there's no as keyword.
Yeah,
Okay.
I'm not sure. Let's see if this works. It does work. Yeah, so you can write it like this.
Okay. Yeah, that makes more sense.
Tutors.
Like an alias.
Exactly. All right. So this is right, and this type of problem happens a lot. Like an example is you might have an employees table, but you have a manager ID. All right. So it's like you can think this could have been a manager ID. The manager of Bart, right, is Lisa. And we had a manager ID here. Let me see the questions. Give me 1 second. Yes. Students.tutor_id equals tutors.id. Yes. Cool. All right, so this is so you can think of this as like a self-referential table, meaning like by design, even without, I'll just so you can read it, I'll just put this in a comment. But by design, even if you just look at select all from students, this table references itself. When it says tutor ID, it's referring to the same table, right? To the same table. So, if you see a LeetCode problem like this, you basically have to I don't know how to do this without using a self-join, right? If you see one of these self-referential tables, you basically have to use the self-join. Yeah, so with SQLite, Postgres also has self-joins. Like basically all databases that I know of, right? All relational databases will have self-joins available to them. The next case where you can use a self-joins, and you don't have to do this, right, is kind of like in performing lags. So here you can see we have like this temperature data. I'll just show you it for a second. So you see we have a list of temperatures, and it's really, it's not by day, it's really by month, okay? So select all from temperatures, limit 5. And let's say we wanted to calculate the difference between the max temperature in February from the max temperature in January. Okay? So one way to do this is select all from temperatures, and you could say like as T1, join temperatures as T2. Okay? Let me do this at triple quotes. Now think about this. If we do T1 dot date equals T2 dot date, this is basically going to join the same. Let's just see what happens here. It's going to join, just duplicate this data across. Let's just see that for now. Have it output. So you can see we have the same exact data joined on itself, but we don't want to do that. We want to actually have February link up with January. Okay, so we want to have a row where we see February's data and we also see January's data. So to do that, we can say where T1 dot date, so this February equals T2 minus 1. Equals T2 minus 1. So where February equals where this guy's February is going to link with this guy's January, right? Because T2 minus 1 puts me to January. So let's just see this. T1 dot date equals T2 dot date minus 1. And I hope that works with, it's just annoying that I'm working with months. I probably should work with the ID. Let's do that. T1 dot ID equals T2 dot ID minus 1. Okay? So you can see that, right? Now we have this January date linking with the February date because it's this table's ID equals this table's ID minus 1, right? So this is the next month, right? It's the next sequential month, all right? So now this makes it easy because now I can do, if I want to see the difference in temperatures, right, from February to January, I can do T2, select, let's do, I'll keep the date in both times. So we'll do T1 dot date as T1 date, comma, T2 dot date as T2 date. And then if we want to, see the change, it would be T2 dot max temp minus T1 dot max temp. Right? T2 dot max temp minus T1. So I should get -2 here. Right? So you can see it went down, and you can also so we'll say this difference in temp. All right? So here it went down 2 degrees, and here it went up. Okay? If you want this in strict terms, right? If absolute value doesn't matter, right? Say you want to find the biggest change overall, how would you do this? Well, you need to do an absolute value around this, right? So you'd have to do absolute value. Okay, and now the difference is always positive. All right. And then of course, you can always build on, you can build on this kind of calculation, use the CTE to find what month had the largest overall change in temperature, something like that, or what was the largest overall change in temperature, right? So you can always build off of this. So this is one way to do this, which is to use a self joins. So we're loading the same table up twice, and then we're joining it, right? And you can see, remember the way I did it, I just joined it on itself first, and then I was like, nah, you can join it on 1 month, one kind of day or month backwards. Here I'm using the ID, which is probably the safest to use. All right.
Jeff, I'm wondering if these are actual days, they give the day, this is a European date or something like that, because I'm seeing 27 as the first number. and that's
Oh,
weird.
is that what it is? I get what you're saying. So January 3rd. I see.
Yeah. So I mean, it still
So
works.
it
It's just the difference
would,
in
yeah.
days.
So maybe we could subtract, and I think that's how I did this in the reading. Was I just
Yeah.
subtracted the date, which is probably,
Yeah.
yeah, which would feel safer to me, right? Because if there's some sort of reordering with the IDs, you don't have to rely on that.
Yeah.
Yeah.
Yeah. That's what I was wondering. Yeah.
Yeah, I
Looks
think
like
that's
it's
I think that's the
some
right.
kind of European date. Yeah. Okay.
Yeah, I think that's better. Cool. So yeah, all Wayne is saying is like we could do probably T1. Sorry for this being. Yeah, we're good. So it's T1 dot T1 date equals T2 dot T2. Or is this probably still called? Sorry, it's dot date. It's just dot date. So T1 dot date equals T2 dot date minus 1 probably should give us the same thing. We missed it up. So maybe it does. It could be because it's like a string. I just don't know what that
Yeah. You just have to do some kind of cast or something like that. But yeah,
yeah, you
maybe.
might have to you might have to like extract the
Yeah. The date.
yeah, the date out or cast it to an integer potential somehow. Yeah. So you could like somehow add it. Yeah, but anyway, I guess for now this is easiest. Well, oftentimes you'll just see a number there and you'll be okay. You can just do this kind of calculation. So T1 we had ID equals T2 dot ID minus 1. So for now this works fine. All right, and you can see how we then did this. Once we lined up the tables, then we just subtract the columns. Okay. We line up the tables like this. Okay. So like I said, even just knowing self-joins can really, in one, sometimes people are just expect you to know them, so they're not so impressed. But other times people are like impressed that you know them. But either way, they do come up certainly in interviews as a way just be like, how familiar are you really with SQL? All right, and this is why we make sure we go back over them here. All right. So I really like this this problem, this cross-device users problem that is coming up. One like kind of gotcha in this when you get to this problem is that because I was doing this before class and I was getting it wrong and I didn't know why. And then I remembered one thing you have to worry about here. It's kind of the problem I should do in lecture, which is like, tell me all of the web users who are not mobile users, that kind of thing. One thing you have to worry about though is that the users can show up more than once. Okay, so because these users show up more than once, it's first a good idea to be like, just give me a unique list of these users, right? Just give me a unique list of these users. And that may seem really hard, but it's not. You just have to do select all from, and then instead of selecting all the users, let me just show you. If we do count star, right, this will give me 2021, right? These are all like visits. These are like all visits to the page, but some users visited many times. So instead what you can do is select all from, select distinct user ID from web users. I think like that. Yeah, you see that? So this is now, and if you look at the count here, 1256, right? It's a fewer number. Previously we had select all from web users, right? It was a lot. It was a larger number. It was 2021, right? And the reason why is because, right, the dimension of the data is all visits, and it's counting repeat visits. So instead you can do like select whatever from, but first use a subquery to get a unique list of the users. So just select distinct user ID from web users, right, gives you a distinct list of the users. Okay. So anyway, I give that to help you out. Let me see if there's more questions. Oh, cool. And Wayne shared a resource. We can put that in Slack too. All right. So yeah, so go through self joins. Like I said, we're gonna. They are for like I only learn for interviews basically, but they're good. And I know about them obviously, but they're good to know for interviews. So we'll do this like the outer join practice, then we'll go through the self joins material. Then from there we'll go through cross joins. This is just a short lesson on cross joins, and then from there we can move on to more advanced SQL. We'll do that in another class. The last thing we can do maybe today is just review binary search trees a little bit. All right, and you can skip this Roman numerals problem for now. Cool. All right, let me put you